and welcome once again on the lecture series of course Elements of Machine Design. Myself, Mr. S.S. Mari, Head of the Department Mechanical Engineering, Sharad Institute of Technology, Polytechnic, Andhra. Today we are in the 9th lecture of Elements of Machine Design. Up to this lecture we have undergone Introduction to the syllabus, necessity of the course Elements of Machine Design for diploma engineering students, procedure of design of machine component, what are the different considerations in the machine design. We have also undergone the basic concept of stress and strain. We have studied how the stress strain diagram is formulated by taking a simple tensile test. We have also studied the principal stresses and principal planes. We have also undergone the different properties of the engineering materials. So up to this point we have studied this point. So in today's lecture we will see what is meant by the standardization and what is its necessity, what are the different standards that are implemented in engineering practices for different industries. So let's go through the what is meant by the standardization and what is meant by the standard codes. So before going into the definition of standardization, it is necessary to understand what is meant by the standard. A standard is nothing but a set of specifications of parts, materials or processes. Keep in mind, a standard is a set of specifications for parts, materials and processes. Means we have set some standards regarding the parts, how the parts are categorized, what are the different properties of the parts, according to the properties of the parts, according to the applications of the parts, according to its composition. We have set some standards to these parts, the different materials that we are using in the engineering practices, that is metals and non-metals, and the different manufacturing processes. So we have to carry out these manufacturing processes according to the standards which are given by the different government organizations which are followed throughout the India as well as throughout the world. So basic objective of a standard is to reduce the variety and limit the number of atoms to a reasonable level. Means as a tool for a design engineer, it is very easy or it is beneficial for a design engineer to select a specific standard component for assembling purpose or for manufacturing of a machine or a device. So to reduce the variety at the global level as well as the national level, and to limit the number of atoms at a reasonable level, so it will be easy for an engineer to detect or to pick these parts as per the requirement. With standard, there is another term is associated with the standard, that is the code. So standard is different and code is different. As we have defined that the standard is a specification for parts, material and processes, but code is defined as a set of specifications for the analysis, design, manufacture, testing and installation of the products. Standards gives an idea about the class of an elements. If number of elements are falling in a particular class, then according to standard we can pick that element or that material for a particular designing of a component. Suppose take an example of a shaft. Suppose a shaft having a diameter of 45 mm is categorized in a particular group having the composition, same composition, say 30C8 or 45C8, then these are the standards which are set by the international standard or national standard. But code is nothing but the guidelines, or we can say these are the some guidelining principles how to analyze a particular process, how the analysis is carried out of a particular process or particular element, how to design a particular element, which criteria is to be used for designing a particular element depending upon the stresses induced in that component. We have to follow that different rules or different design procedures. Manufacturing processes, how to carry out a particular manufacturing process, what are the heat treatment temperatures for that particular element, what are the changes in the phases of that particular element, which phase has which properties, how to carry out quenching of that media, how to carry out the heat treatment processes. So these are the some different codes that are set, and according to that codes we have to follow that design procedures, we have to follow that testing procedures. Suppose if we want to test a particular solar flat plate collector, then according to the codes which are set for testing a flat plate collector, we have to follow the same codes, and after testing that flat plate collector, then we can conclude the efficiency of the flat plate collector. So these are the some guidelines which are provided for testing, for manufacturing, for design, and for installation of the different elements, different machine components, different devices. So standards are different and codes are different. We are interested in the standards. Now, after understanding the definition of code, the purpose of code is to achieve a specified level of safety. Means, as a design engineer or as an engineer, if we follow a particular code for erection, for testing, for analysis or design of particular element, then it is, we can reliable, or we can say that a particular level of safety has been achieved through following this kind of a codes. So these codes are important with the standards in an engineering practice. So after understanding the difference between standard and code, we will move towards the standardization. Why standardization is necessary? As defined here, standardization is defined as obligatory norms, or what we can say compulsory norms, to which various characteristics of a product should agree with the standards. In some standard has been set for that particular product, for that particular element, but the norms which are concerned with that elements, the characteristics of that element should agree with the standards. The standards which are set for that particular product, for that particular element, for that particular material, these characteristics should be compile or agree with the standards. This procedure is known as the standardization. Means to compare whether that element, whether that product, whether that process is following the standards which are given by the national as well as the international level. And doing this analysis or carrying out this process is nothing but the standardization. The different characters which includes in a process of standardization are materials, types of the materials, dimensions of the component, and the shape of the component. How this material is tested, how that element is tested, how the marking has been carried out, how the packing of that element is carried out, how to store that element. Now, according to the storage temperature, according to the method of packing, according to the marking methods, we have to group some elements, we have to group some processes. That grouping according to the standards, comparing with the standards, is nothing but the process of standardization. As we have discussed the standards and codes, there are total 3 types of standards that are followed in the engineering practice. The first is the company standards. In simple language, these standards are used in a particular company or group of sister companies. Means a particular company, particular organization has formulated some standards. Now, according to the formulation of that standards, that organization works. Means that organization follows these standards only which is concerned with their private organization. Though it is a government organization or a private organization, these standards are only followed at the company level. And each and every company may have different standards according to their criteria, according to the nature of the organization, according to the manufacturing processes, according to the elements, according to the service industries, according to the type of the industries. These industries set standards themselves, and these standards are followed. Means it is compulsory for all the people who is working or who is associated with that company to follow the company standards. Next is the national standards. Means the standards which are followed at the national level. Means at a country level. Means each and every country has their own standards. India has different standards, Germany has different standards, USA has the different standards for the same process, for the same element. If the same process is going to be carried out in USA and India, then India has to follow the standards which are governed by the Indian government. The standards of the pollution norms. Simple example. India has to follow the pollution norms as per the Bureau of Indian Standards. Bharat Stage, BS4, BS5. Germany has to follow the standards which are set by the Dutch Institute for Normung. USA has to follow the American Iron and Steel Institute. British standards are there. So each and every country has their own standards, and according to the standards which are set by their own country, that all the organizations which are associated with that country, with that national, they have to follow the national standards which are set by their own country. These are the national standards. And last one is the international standards, that we all know that these are formulated by the International Standards Organization, and these standards are followed at worldwide, at the global level. It's all the country has to follow that standards for a particular process. If a particular process is there, for say the example of testing of flatbed collector, if some standards has been set by the International Standard Organization, then all the countries are mandatory to follow the same standards for the testing of the flatbed collector and to determine the efficiency of the flatbed collector. So these are the international standards. Now, what are the different standards that are used in the mechanical engineering design? If we take engineering design, then which kind of standards are used for the mechanical engineering design? Say, just have a look at one by one. The first standard is for materials, their chemical composition, mechanical properties, and heat treatment. Now the standards which are used for the materials, their chemical composition, their mechanical properties, and heat treatment. Take the example. Now Indian standard, now this is the national level standard. Indian standard 210 gives an idea about the grades of grey cast iron. Now according to Indian standard IS 210, there are total 7 grades of grey cast iron has been specified by the Indian government, and these are designated as the FG. Now FG is used for the grey cast iron, and the number 150 indicates the strength of the grey cast iron in Newton per mm square. So according to IS standards, according to Indian government, Indian standard, 7 grades of grey cast iron has been specified according to their chemical composition, according to their mechanical properties, and according to the nature of heat treatment process. Now this is the only example. You can also specify the same for the steel also. You can specify the same for the aluminum also. So these are the standards which are set for the material properties, its chemical composition and its heat treatment processes. Now next standard which is set by Indian government or Indian standard is the standard for shape and dimensions of commonly used machine elements. Take the example. According to IS 2494, this Indian standard 2494 specifies the dimensions and shapes of the V belts which are used for the power transmission. This is a simple example. According to IS 2494, this standard gives the dimensions and the shapes of the V belts for power transmission. First we have seen the standards for the chemical composition, mechanical properties and heat treatment process. This standard IS 2494 gives or specifies the dimensions for the shapes of the cross section of endless V belts which are used for the power transmission. If you go into the IS 2494 standard, then you will get the idea about the dimensions, power transmitted by the V belts, angles of the V belt, material used for the V belt. You will get all the data regarding the V belts in the standard IS 2494. Now next standard is the standards for the fit, tolerances and surface finish of the component. Now which kind of the fit are necessary, what are the different types of the fit, how these fits are considered, what are the different types of the tolerances, when we have to give the tolerances, how much tolerance is provided for a particular component, what is the requirement of the surface finish, how the surface finish is specified, what is the number of surface finish, for which application which kind of a surface finish is requirement. These all set are given in the Indian standard for the fit, tolerances and surface finish. If you take the example of this, then IS 2709, that is the Indian standard 2709, gives and guide for selection of fits. Means for a particular designing of an element, how to select a particular fit, a clearance fit or interference fit or transition fit. These all guidelines are given in IS 2709. Now it is the one of the example. Number of guidelines are provided, say IS 2709, IS 2710, IS 2711. So there are different types of guidelines are provided regarding the selection of the fits. Say a simple example, the tolerances or upper and lower limit for various size of holes and shafts. Now you have studied the hole size, shaft size in engineering metrology. You have studied also the types of the fits. You know what is meant by the tolerances, how the tolerances are specified, what is meant by the hole basis system, what is meant by the shaft basis system, how the tolerances are specified. Now these all guidelines are provided in this Indian standard. If you take a simple example, IS 919 gives and recommendations for limits and fits for engineering. Now as this IS 2709 provides guidelines for selection of fits, in the same manner IS 919 gives and recommendations for limits and fits for engineering practice. In the same way, IS 10719 gives an idea about indicating surface texture on technical drawings. How to indicate a surface texture value on technical drawings. This data can be given in a standard 10719. Next example is the standards for testing of products. How to test a particular product, how the standard procedure for the testing of a particular product. This all information is specified in the standards for testing of a product. These standards are sometimes called codes, which gives the procedure to test the product. Say example, say pressure vessel, boiler, crane and wire ropes, where safety of the operator is an important considerations. Means if you want to test a particular boiler before actually running, if you want to test a pressure vessel, then we have to follow the standards which are set for the testing of the product, the codes which are set for the testing of the product. Say for example, IS 807 is a code of practice testing of design, manufacture, erect and testing of cranes and hoist. Now we know that what is the use of crane, what is the use of hoist. If you want to test these cranes and hoist before actually coming into the application, before actually using in the application, then you have to test, you have to design, you have to manufacture and you have to install these cranes and hoist according to testing code IS 807. Take another example, the method of testing of pressure vessel. If we want to test a particular pressure vessel, whether it is sustainable to a particular pressure, then we have to use a testing code of IS 2825. That IS 2825 gives a code for unfired pressure vessels. Now according to this code IS 2825, if we want to test a particular pressure vessel, say unfired pressure vessel, then we have to follow the procedure which is set by Indian Standard 2825 for testing of a pressure vessel. Next is the standard for engineering components. We are using different in the engineering components for day-to-day applications. Take a simple example of SP46. This is a standard which is prepared by BIS, Bureau of Indian Standard, on engineering drawing practice for schools. Engineering drawing practice for schools. We are using the engineering drawing books, say by Bhatt, or we are using engineering drawing books, reference book of different authors. Now these engineering drawing practice for schools are specified by this SP46. According to SP46, there is a special publication SP46 prepared by Bureau of Indian Standards on engineering drawing practice for schools and colleges, which covers all standards related to engineering drawings. That is SP46. So these are the different standards used in the mechanical engineering design. That is standard for chemical composition, mechanical properties and heat treatment, standards for shape and dimensions, standards for specifying fate, tolerances and surface finish, standards for how to test a particular product, and standards for commonly used engineering components. So next move to the what is the benefit of standardization. Why we are recommending the standardization? We know that standardization is the comparison, or we can say a compulsory norms to which various characteristics of a product should agree. If we take a particular product, then characteristic of that product should agree, should have agreement with the standards which are set by national level or international level. This is known as standardization. Then why this standardization is necessary? What is the use of standardization? What role it will play for an engineering industry? Why it is necessary for the mechanical engineering industry or any industry to have a standardization? The first thing is it will reduce the type and dimensions of identical components. Means if you take an identical component, say shaft, then according to the type of shaft, hollow or solid shaft, and according to dimension, it will group the shafts, it will group the keys, it will group the couplings, it will group the levers, and for a design engineer it will be easy to pick that lever or that shaft according to the dimension and its types. Means it will reduce the inventory control, means it will help in maintaining the inventory control for any organization. Next is the reduction in manufacturing facilities. Due to the standardization, if standard components are available in the market, then as a design engineer it will follow or it will give the preference to pick up that standard components from the market rather than manufacturing that component in a own industry. That will reduce the requirement of the different manufacturing facility. Interchangeability, you have understood, you have actually undergone this concept interchangeability in metrology and quality control. Engineering metrology, you have studied this interchangeability concept. Means easy to replace. It is easy to replace a particular damaged part. It is easy to replace a part in any assembly if that standardization is implemented, if that standards parts are available with a design engineer, then it will be easy for that engineer to replace a particular part if that assembly, if that machine, if that device is not working properly. Next is the no need to design or test the elements. If a particular element or if a particular product is available which is following the rules of standardization, which is agreement with the standards, then it is not necessary to design again that same component. If you take the example of a shaft, say if 45 mm diameter shaft is available which is standardized according to IS rules, which is having this much tensile strength, it is having this much surface finish, the material of this shaft is this, the dimension of this shaft is this, then according to the application I can directly choose that shaft from the machine design data book. There is no need again to design the same shaft for the requirement and to test that element. So if standardization is implemented, then easily one can pick that part for a particular application. Now as the standards parts are available in the market, or if the standardization is followed, by default quality and reliability of the process will improve, because we are using the quality parts, we are using the quality elements which are reliable, which are already tested according to the rules set by the IS standards. Now if these parts are reliable, then we can easily pick up that parts for a particular application. Now it will improve the reputation of the company which manufactures standard components. Simple. If any company is following the rules of standardization, if any company is following the rules codes of the standardization, if it is following international national standards, then it will give a marking to that company that this company is following the rules which are set by the international standards, which are set by the Indian standards, and according to the rules which are set by the standardization, this company is manufacturing a particular component. That means that quality, that reputation of that company improves, which by default helps that company to gain some name in a market. Next is it ensures safety. As we know that testing of a particular pressure vessel for a particular pressure, if I am following the rules of standardization for testing of that particular pressure vessel, that means I have tested that pressure vessel for a particular pressure. If I am following the standardization, that means according to that standardization I have tested that pressure vessel, and I come to conclude that the pressure which is mentioned on this pressure vessel, it is performing well below that pressure, and I am following the standard procedure for testing that pressure vessel. Means there is a less chances of accidents of that pressure vessel. That means it will ensure the safety, and by default, due to these all things, due to these all parameters, it will reduce the overall cost of production. That is the aim of any design engineer, that is the aim of any mechanical engineer, to reduce the overall cost of production. If there is a less inventory control, if we are following the standard parts, we are using standard parts, if it is having the less manufacturing cost, if it is easy to replace, if there is a quality product is manufactured by the company, then it will all add to the results in the overall cost reduction. So this is regarding the standardization. What is meant by standard, what is meant by code, what are the different standards which are used in the engineering practice, and what is the necessity of the standardization, what are the benefits of the standardization. I hope you have understood what is the meaning of standardization, the benefit of standardization, and how we have to follow the standards. Thank you.